What I would like to talk to you right now in the next 20 minutes is what problems we have in mountain emergency medicine, but also maybe a little bit less in high altitude medicine, and whether we have some possibilities to solve these problems with a new tool which we will have in a year at the Institute of Mountain Emergency Medicine in Bolzano in Italy. So I'm paid by the EURAC research and did a lot of research in mountain emergency and high altitude research in the last 20 years, but I have no financial conflict of interest to disclose. This is my workplace. I'm working in Bolzano. My institute is part of the European Academy, and we are a group of researchers and dealing with all aspects of mountain emergency medicine. That means the emergency medicine questions and problems of the roads. So where the ordinary ambulance cannot reach the patient, so we get active, and this is the field of research we are working on. So especially on the cold injuries, which is our core competence, but also circulatory arrest and, for instance, resuscitation questions in an environment which is very harsh and in remote areas. This is the group. We are from different countries, and but especially we are very interdisciplinary, and we have collaborators from different areas of research, and technicians, engineers, neurologists, specialists in internal medicine, in physiology, emergency medicine, biologists, informatics sciences, and also in languages. So we are a complete team, and I think we can work from the A to the Z on research. If we have a question, we can start with the idea and conclude a study with a publication. So let me look at the history of literature, or in other words, of science in mountain emergency medicine. And if we look at the number of publications in the last decades, we can see that in spite of the first issue of Tintinalli's Emergency Medicine in the 70s, the emergency medicine in mountain and remote area remained asleep for a long time, and only in the last decades, 2 decades, there was a boosting of literature about mountain emergency medicine with some keywords: mountain rescue, avalanche, accidental hypothermia, etc. And this means that we are a very, very young discipline in medicine. But if we look at the kind of publications, we have to admit that more than half of all publications are publications without original data. So almost half of them, of the publications, are case or reviews, recommendations, position papers, comments, editorials, etc. And only 49% are publications with presenting original data. And this, I think, is much lower than in other disciplines in medicine. Probably also much lower than in high altitude medicine. So why is this in emergency medicine so difficult? There are some inherent limitations in the kind of study. We are working mostly with very small sample sizes and have a lot of external confounders. But not only in our field, we have a high inter-individual variability in the studies. I'll give you only one example. The randomized clinical trials on out-of-hospital cardiac arrest, the big ones and the most famous ones, for instance, on mechanical chest compression, the LINK study, worked with 2,600 patients over a duration of 5 years, and this is an extremely high number. Similarly, Nielsen and Kim on targeted temperature, also randomized clinical trials over only 2 years, 5 years, with a number of 1,400. So if we calculate the incidence per year, so we have hundreds of cases. But on the other side, if we look at the studies on hypothermia, always the same issue, out-of-hospital cardiac arrest. All those studies are retrospective, so they have a lower level of evidence, and they have an extremely low sample size of 48, 28, 46. But not only that, they go over a period of decades, 15, 20 years, 16 years. That means that the incidence is almost neglectable. And you can imagine that patients 20 years ago were not treated the same way, and the circumstances were completely different than in the last years. So they are not well comparable. It's nothing new to you as experts in scientific work that small sample sizes give us huge statistical problems. And if you have two distribution curves that are low, small, and broad-based, the overlapping area is very big, and this gives us complex problems and high statistical errors, because the statistical error itself is underestimated in many cases with small samples, as it itself has a large variability. And last but not least, you know that only the confidence interval factors depend strongly on the number of cases. I'll give you another example for that. We calculated the survival probability of completely buried avalanche victims in the last years and compared the two samples in Switzerland with the Swiss with the Austrian sample. And on a first glance, they seem similar, except one period between 35 and 60 minutes. And we could say from that there is a bigger chance of survival in Austria than in Switzerland, because we have a better outcome of those patients in Switzerland compared to Austria. This was calculated with a very complicated algorithm, the so-called Turnbull algorithm, which is very suitable for survival probabilities if you don't know whether the death was before or after an extrication time. So left and right censored data. But if we look in detail into this short period during the burial, then we can see that just in this period, the number of extrications was very low, and pure numerically, the difference is not significant. So this is very much misleading, and we have to be very careful. Another problem is the inter-individual variability. We measured the optic nerve sheath diameter in persons acutely exposed to high altitude of 3,800 meters, and found a big noise in the baseline. And of course, you can you can make a baseline correction, and you can also measure only the delta, the difference. But it makes a difference whether a point starts from almost zero or the point, the basal value starts from a higher value, and the difference is different, and the effects are different in both. So this has to be considered. It's not that easy. But not only statistical errors. We have a lot of external confounders. When we go out in the field, and the field study on the Ortles, for instance, or trekking to the Everest Base Camp, we have extreme ambient temperatures that have been underestimated in the last studies, probably. We have variable barometric pressures, depending on the weather. We have variable humidities, precipitations, UV radiations, so there are a lot of external confounders. And as Peter already said, field studies are very adventurous. That's nice, and people like field studies because they can combine mountaineering with science. Nothing to say, but it is difficult to keep a high quality of the studies because the field studies, many times, this was our experience in the last years, or sometimes very unpredictable. It was Sir Karl Popper, the philosopher of science of the last century, who said in 1934 that non-reproducible single occurrences are of no significance to science. And I think this is a principle. This principle maybe was also undervalued for decades, and it was brought up in the last years by the two leading journals, Nature and Science. First of all, by two persons. One was Monia Baker, editor of Nature, who made a survey between medical researchers, and half of the researchers stated that their study is not reproducible. And this was a kind of alarming, and this was also confirmed by Drummond, Rennie. And Peter, I think you know Drummond. He is in California at the university, is working since 40 years on evidence-based medicine, and he's one of the promoter of evidence-based medicine, and he also confirmed this problem of a lack of reproducibility in science. But what can we do against this if the sample size is small and we have a lot of confounders? Theoretically, we can increase the sample size. And there is the possibility to establish international registries. Currently, we have 3 working registries. One is the oldest one is the hypothermia registry of Beat Walpott in Geneva, and it is well working. In a few weeks, he will present in Tromsø the first 100 cases of this registry, and it is a multi-center study. Then we have 2 international registries, one about the alpine trauma. It's working since 4 years, and we have already published the first results. And the second one will be the International Avalanche Registry, which is also expected to be an international registry in Switzerland, Germany, Austria, and Italy. Hopefully it will work. It is quite complex to gather pre-hospital data and to link the pre-hospital data with in-hospital data for privacy reasons and etc. And also because there is no flow of data from the site of the accident to hospital in many cases. And there is envisaged a registry on HAPE and HACE2. Second possibility would be to control the confounders, to see whether we can control the climate factors. And here we may have in the future a new possibility. We were convincing the local government to give us a laboratory, which can simulate the climate and also altitude. And in Bolzano, it is in the way of construction, the technology park. This is part of it. And in this technology park, we will have this kind of a box of concrete, and it is of tons of concrete. And here you see the big door for the entrance of also big machines and vehicles that can be tested inside the chamber by the industry. And a few days ago we had it was a kind of a ceremony when the roof was completed, and it is now in the phase of construction, and it will be finished in a few months. So this is a chamber, a hypobaric and a climate chamber that can simulate many factors at the same time or individually. It is for multifunctional use, not only for medical research, but also ecological research, and it is a joint venture with the industry, so the industry can test their material inside the chamber, but I think it is the first hypobaric chamber which is really dedicated to human research, which is open to the public and to any institution, because the hypobaric chambers in the world, they are or for military use or for industrial use, as the BMW has a big chamber, hypobaric chamber, that goes up to 5,000 meters, but it is absolutely not open to human researchers. It is big enough to host more people. It is 12 meters per 6 per 5. 5 is the height. And we can simulate the temperature down to minus 40 and increase to up 60 centigrades above zero. We can regulate the atmospheric pressure up to 9,000 meters, but we can also simulate normobaric hypoxia up to 9,000 meters, so we can compare maybe randomized and blinded the hypobaric and normobaric hypoxia in this chamber. We can produce wind, humidity, rain, snow, and in some cases also UV radiation. It consists of a series of chambers, of rooms. There is, first of all, the test chamber, which is big enough to host 15 persons, and they can stay inside the chamber also for a long term, up to 40. It is designed for a stay inside the chamber up to 45 days. And there is an airlock where we can change the pressure very fast, whereby we can change it in the large chamber much slower than in the airlock. Then we have an ambulatory room where we can keep the pressure higher, simulate lower altitudes for the doctors or for those persons, the researchers who are testing the subjects. And there are toilets and bathrooms, a bathroom, and a control panel where the technicians and the researchers stay and monitor the subjects. And the subjects are all at the same time continuously monitored with the ECG, with the blood pressure, oxygen saturation, and core temperature. this is these are the basal measurements during the tests. We hope that we will be punctual with opening the chamber on the 30th of November this year, and it should be operative next year, about in 1 year. Project submissions are welcome right now. It's open for submissions, and there are two possibilities. If anyone wants to do a study, it can be done completely independent from our institute, so the part of the chamber will be completely sealed off from our institute's area, also in terms of data flow, for instance, or you can collaborate with EURAC and together with us, and we can also provide the safety of the chamber and take the responsibility of safety and during the tests. We are, of course, very grateful to find partners for collaborative applications for EU funds and national grants. We have already funded studies for the next year together with partners in other European countries, but it will cost, but we will hope to keep the costs as low as possible. And to give you a number, it depends on the functions of the chamber. If you in the most expensive case, if you want to have the lowest pressure possible, the highest wind speed, etc., and the highest temperature or the lowest temperature, so to run the full possibilities of the chamber costs about 2,000 euro per day. But this will be lower if the energy costs are lower, and so this to give you an idea. We will also open calls, competitive calls, which are sponsored by our government, so that every year, I would say 1 or 2 studies are reserved for partners who are not able to finance their own studies. So in all cases, please contact the Institute. What we can offer, it sounds a little bit sensational, but we try to offer safety, control, and a better reproducibility of the studies and try to increase the evidence. So what we do not know is are differences, for instance, between hypobaric hypoxia and normobaric hypoxia, as it has already been said in the morning session. And we suspect that up to an altitude of 3,500, 4,500, the differences may be small. They are ventilatory differences, but in the outcome, in the symptoms, the clinical relevance may be not that big, but at higher altitude, the differences will be bigger. That's our hypothesis. And the future will bring. There are very, very little evidence about the difference between hypo and normobaric at a higher altitude, because it's not possible to do the studies. I would like to take the opportunity to announce the next World Congress of the International Society of Mountain Medicine. It will be in Kathmandu. So we are very proud to go to Nepal for the first time with this highly interesting issue, which will address also the problems in the Himalayas, not only in Europe and North America, but problems which involve Sherpas, the civil protection, disaster preparedness in Nepal. So this will be a topic which go beyond high altitude medicine, and we will also combine high altitude and mountain emergency medicine. Would be nice to see you there in Kathmandu. You will be welcome. Thank you very much.